All right, y'all, we've got quick notes today and we have 2 new topics. So first, make sure you get your notes title in your notebooks. And then first thing we're going to talk about is the fundamental theorem of algebra. All right, so make sure that you write this down. Write down this little note right here. This basically summarizes the fundamental theorem of algebra. It says the degree equals the number of factors equals the number of solutions. So really quick, let's make sure we break these down. The degree is the highest exponent in a polynomial. So the degree of a polynomial tells me how many factors that polynomial has and how many solutions that polynomial has. All right, so let's do a quick example. We have this little check for understanding here. So given f of x equals x cubed plus 4x squared minus 3x plus 2, how many factors should f of x have? And how many roots or solutions should f of x have? I want you to tell me what you think based on the fundamental theorem of algebra. How many factors and how many roots should this function have? All right, so the fundamental theorem of algebra says if you're looking for the number of factors or the number of roots, all you have to do is check what the degree is. The degree is the number of factors. It is the number of roots. So the degree is going to be that highest exponent. In this case, the degree is 3. So we're going to write a little note down. Degree is 3 here. So f of x has 3 factors and 3 roots. Yay. Okay, so that's the fundamental theorem of algebra. Now let's go into another topic. How to factor a polynomial using division when we are given one factor. So get this down in your notes. Factor a polynomial using division when given one factor, and then make sure you write down this whole example problem. All right, so here's what we're working with. Given that x plus 3 is a factor of f of x equals x cubed minus 7x plus 6, write f of x as a product of 3 linear factors. Okay, really quick, let's make sure we know what this word means. So what does product mean? What operation? Product is multiplication. So this is telling us to write f of x as multiplication of 3 linear factors. Okay, so how do we do this problem? We start with step 1. Over here, step 1. Factor by dividing by a known factor. All right, this tells us we know a factor. Based on the problem, we know that what is a factor? X plus 3 is a factor of f of x. Okay, so really quick, let's make sure we know exactly what that means. Since x plus 3 is a factor of f of x, this means, and you should be writing this all down in your notes, this means that when we divide f of x divided by x plus 3 divided by that factor, based on the remainder theorem, since x plus 3 is a factor, the remainder equals 0. That's something that means. If x plus 3 is a factor, that means when we divide, we should get a remainder of 0. And then let's remind ourselves of one more thing. Division gives us factors on the outside of the box. On the outsides of the box. Division gives us factors on the outsides of the box. So we're going to divide. We're going to divide. Here we go. So let's go ahead and draw our box. I'm going to draw this in green. Woo. Okay. So we're drawing our box. Remember, I don't stress about the number of squares. Don't need to stress about that. Okay. So division gives us factors. Factors go on the outside. Well, what is a factor that we know? We know that x plus 3 is a factor. X plus 3 is going to go on the outside. X plus 3 is a factor. And then when we divide, we put the numerator on the inside. If you recall, we put the numerator on the inside. So let's go ahead and get the numerator. What is the numerator? F of x, right? So this f of x is our numerator. Make a note of that. And we want that on the inside. So what we're going to do is we're going to put x cubed on the inside of the box. And then we're going to do our division, reverse engineer the box. So what needs to go on top? X squared, because x times x squared gives me x cubed. Then what goes inside? We get 3x squared. Well, how many x squareds do I see in my numerator? I don't see any x squareds. Hold on, let's make a note up here. 0 x squareds. There's none. So these two need to cancel. The 3x squared and whatever goes in this box needs to make up 0x squareds. So I'm going to put negative 3x squared right there. All right. Then we need to continue to fill out the top. So we get negative 3x. Let's keep going. 3 times negative 3 is negative 9x. How many x's do we see? We see negative 7x, so we know that this negative 9 and whatever goes in here needs to add up to negative 7. So we're going to have positive 2x. And then 2 is going to go on top. And last, we get 6 on the inside. Let's make sure we ended with what we needed. We have 6 on the inside of our box. We needed 6. Well, what did we say the remainder would be? What did we say the remainder would be when we divide by x plus 3, a known factor? Remainder would be 0. That's right. If you end with what you need, we ended with what we needed, so the remainder equals 0. Cool. All right, so here's the thing. The factors are on the outside of the box. Factors are two things that multiply together to make like another thing, right? Okay, so the factors of f of x, the two things that factors are a number of things that multiply together to give you what you need. So the factors of f of x are on the outside of this box. These two things multiply together to give us f of x on the inside. Factors are on the outside. So we can say f of x, yes, f of x can be written as this thing right here. So let me write that down. F of x can be written like this, x cubed minus 7x plus 6. That's like the f of x that we started with, right? But it can also be written as two factors multiplying together. So f of x can also equal this x plus 3 factor and this x squared minus 3x plus 2 factor. Okay, this right here is a product, right? There's multiplication happening. Product of how many factors do we see here? 2. So this is a product of 2 factors. Well, the problem asked us to find a product of three linear factors. Up here, it said, right, f of x is a product of 3 linear factors. So what do we need to do? We need to continue factoring until you can't anymore. So which one of these 2 factors can I factor more? This thing. So let's go ahead and factor that. We're going to use the box to factor that. So I'm going to kind of bring that over here. We need to multiply to 2, and we need to add to negative 3. Let's go ahead and put our x squared here, our positive 2 here. What multiplies to 2 and adds to negative 3? That would be negative 2, and then throw an x on that, and negative 1. That multiplies the positive 2, adds to negative 3. Sweet. Now let's go ahead and write the 2 factors that come from this one longer or larger purple factor. So GCF on this row, we have x. GCF on this row, we just have 1. GCF on this row, we have x. GCF on this row, we just have 2. Now let's make sure these multiply to the correct thing. So x times x gives me x squared, yes. X times 2 does not give me negative 2x, so I need to put a negative on that 2. 1 times x, I need negative 1x, so put a negative on that 1. And now they multiply all to the correct thing on the inside of the box. Okay, cool. So now we can say that purple thing, that x squared minus 3x plus 2, that is the same as x minus 1 and x minus 2. Those two factors. So let's go ahead and write our final equation for f of x. F of x equals, we have the x plus 3 factor that they gave us. They told us that was a factor. And then we factored more using division, and then we factored more using the box to get x minus 1, x minus 2. Sweet. We have now written f of x. We have now written f of x as a product, multiplication. These factors are multiplying. This is a product of 3 linear factors. And basically, we just factored f of x all the way using division, right? All right. So now let's do some practice.